All around us, a silent, invisible world is at work, constantly humming with activity. It's a world we often take for granted, yet it underpins so much of our modern lives. It lives inside our phones, powering the apps we use every day, connecting us to friends, family, and information across the globe. It's in our cars, guiding us with GPS, managing engine performance, and even assisting with safety features. And it's on the very screen you are looking at now, bringing you this content, this story, this exploration. This world is built not of brick or stone, not of wood or metal, but of language, programming languages, the very foundation of our digital age. These special languages are the bridge between human ideas, our creativity, our aspirations, and the cold, hard logic of a computer, translating our thoughts into actions within the digital realm. They let us command, giving us the power to instruct machines to perform complex tasks, create, allowing us to build software, design websites, and craft digital art, and solve problems on a scale once thought impossible, from predicting weather patterns to curing diseases. Think of a computer as an obedient assistant, incredibly fast, precise, but needing clear, step-by-step instructions, a detailed roadmap to follow. Programming languages provide the vocabulary and grammar, the very building blocks for these instructions, ensuring that the computer understands exactly what we want it to do, each with its own rules and strengths, its own unique way of expressing commands. Some are built for speed and power, optimized for demanding tasks and high-performance computing, others for simplicity and accessibility, making them easier to learn and use for beginners. The story of programming languages is a story of innovation, a testament to human ingenuity, of brilliant minds inventing new ways to speak to machines, constantly pushing the boundaries of what's possible. We'll travel from the earliest attempts, from punch cards and vacuum tubes, to communicate with machines, the first tentative steps in a digital revolution, to the rich ecosystem of languages that power our world today, a diverse and ever-evolving landscape. This is not just a technical history, it's not just about code and algorithms, it's a human story of creativity, of problem-solving, of collaboration, and the drive to shape our world through code, to build a better future, one line at a time. Welcome to the hidden language of our world. Prepare to be amazed. Our story begins in the 19th century, a time of great innovation and mechanical marvels, with Charles Babbage's analytical engine. This ambitious project, though never fully realized in Babbage's lifetime, laid the conceptual groundwork for the modern computer. Alongside Babbage was Ada Lovelace, a brilliant mathematician, and her visionary notes. Lovelace went beyond mere calculation. She imagined a machine that could follow instructions to create, not just calculate numbers, but potentially anything representable in symbolic form. She meticulously wrote what is now considered the first computer program, a set of instructions for Babbage's engine to calculate Bernoulli numbers. An incredible feat, especially considering this was all conceived before computers even existed in physical form. Fast forward a century, through world wars and technological leaps, the first electronic computers like ENIAC were massive, filling entire rooms with vacuum tubes and wires, and programming them wasn't about typing code, it meant physically rewiring machines, a painstaking and error-prone process, or, alternatively, flipping switches on enormous control panels. This was programming at its most basic, directly manipulating hardware, a far cry from the software we use today. All instructions had to be given using only ones and zeros machine code, the language the computer understood natively. Imagine writing a letter, or even a novel, with just 2 symbols. That's how early programmers worked, painstakingly crafting every operation, translating every command, no matter how simple, into long strings of binary. One mistake, even a single misplaced zero, could crash the whole program, and finding errors was painstaking and time-consuming. It quickly became clear to everyone involved that a better, more efficient way was desperately needed. Scientists and engineers, the pioneers of this new frontier, wanted to express ideas more naturally, using something closer to human language without manual rewiring or directly manipulating binary. They needed a translator, a bridge between human thought and machine execution. Something to convert human-like instructions, written in a more understandable format, into the machine code the computer could execute. This fundamental need sparked the creation of the first true programming languages like Fortran and COBOL. The age of abstract instruction, where programmers could focus on logic rather than low-level details, was about to begin. The world of code was ready to evolve, to become more accessible and ultimately more powerful. The 1950s brought the first great leap. Fortran. Created at IBM, Fortran let scientists write equations almost like standard algebra, which the computer translated into machine code. Suddenly, complex calculations took hours instead of weeks. Fortran powered scientific breakthroughs and is still used in high-performance computing today. Meanwhile, business and government needed a language for managing data. Payroll, inventory, records. Enter COBOL, designed in 1959 with help from Grace Hopper. COBOL used plain English commands, making it readable even to non-programmers. It became the backbone of banking, insurance, and government systems. For decades, COBOL ran the world's commerce, and much of that code still runs today. Fortran and COBOL opened new worlds, science and business, each with a language tailored to its needs. These languages proved that code could be both powerful and accessible. They set the stage for the next wave of innovation. Programming was no longer just for experts, it was becoming a tool for entire industries. The digital revolution was underway. As computers shrank in the 1960s, a new idea emerged: make programming accessible to everyone. At Dartmouth, John Kemeny and Thomas Kurtz created BASIC, beginner's all-purpose symbolic instruction code. BASIC was simple, interactive, and easy to learn, using English-like commands. Students could type commands and see instant results, making programming feel like a conversation. The real explosion came with the personal computer boom of the late 1970s and early 1980s. Home computers from Apple, Commodore, and others shipped with BASIC built in. For millions, BASIC was their first taste of programming, writing games, automating tasks, and exploring creativity. BASIC demystified computers, turning them from mysterious boxes into creative tools. Its greatest impact was cultural. It taught a generation that anyone could learn to code. Many tech leaders started with BASIC, planting the seeds of today's digital world. BASIC's legacy is digital literacy for the masses. The doors to programming were now open. While BASIC brought programming to the people, a revolution was brewing at Bell Labs. Dennis Ritchie and Ken Thompson needed a language for building an operating system, powerful, efficient, and portable. They created C, a perfect balance of low-level control and high-level readability. C let programmers write fast, efficient code that could run on many types of computers. The Unix operating system written in C spread rapidly through universities and research labs. C became the language of choice for building serious software, operating systems, databases, and more. Its influence is everywhere. C inspired C++, C#, Java, and many others. Even today, C powers the core of Windows, macOS, Linux, and countless embedded systems. When speed and control matter, developers turn to C. C is the ultimate set of power tools for building the digital world. Its legacy is unmatched. C is the foundation beneath modern computing. The quiet revolution at Bell Labs changed everything. The world runs on C. The 1990s brought a new frontier, the World Wide Web. Early websites were static, text and images, but little interaction. Netscape wanted dynamic, interactive pages, so they hired Brendan Eich. In just 10 days, he created JavaScript, a lightweight language for the web browser. JavaScript let web pages respond to clicks, validate forms, and create simple animations. At first, it was seen as a toy, but as the web grew, so did JavaScript. It became the only language that ran natively in every browser, making it essential for web development. Technologies like Ajax turned JavaScript into a tool for building rich, responsive web apps. Platforms like Node.js brought JavaScript to the server side, powering entire websites. Today, JavaScript is everywhere, from social media to complex online applications. It's the engine of the interactive web. The web as we know it runs on JavaScript. In the late 1980s, Guido van Rossum set out to create a language that was powerful, clean, and fun. He called it Python, inspired by Monty Python's Flying Circus. Python's philosophy, simplicity, and readability. Its syntax is clean, using indentation to organize code, almost like reading English. Python lets developers express ideas in fewer lines, boosting productivity. It became popular in universities and science, perfect for teaching and data analysis. Python's vast standard library made it easy to handle common tasks. In the last decade, Python exploded in popularity, thanks to data science, machine learning, and AI. Libraries like NumPy, Pandas, and TensorFlow made Python the go-to for big data and AI. Today, Python powers everything from web apps to space exploration. Simplicity and elegance made Python a global powerhouse. Today we live in a world of diverse programming languages, a symphony, not a solo. There's no single best language, each has its strengths for different tasks. C++ powers high-performance games. Swift and Kotlin drive mobile apps on iPhone and Android. Go, created by Google, builds fast, reliable network services for the cloud. Rust, sponsored by Mozilla, focuses on safety and performance, ideal for critical systems. Modern programmers use a toolbox of languages: JavaScript for web, Python for data, Swift for mobile. These languages often work together, communicating over networks to create seamless experiences. Specialization has replaced one-size-fits-all. The result: incredibly sophisticated systems, built by teams using the right tool for each job. The modern programming landscape is collaborative and interconnected. Our technology is richer and more powerful than ever. The orchestra of code plays on. From Ada Lovelace's pioneering notes, a glimpse into the future of computation, to today's symphony of languages, a complex orchestra of code that hums beneath the surface of our lives. Programming has reshaped our world, weaving itself into the very fabric of our existence. Every time you use a phone, tapping and swiping with ease, stream a movie, enjoying instant entertainment, or order coffee with a few taps on your screen, you're interacting with the legacy of these languages, a testament to human ingenuity. A simple app might use Swift or Kotlin, crafting a user-friendly experience, send data to servers running Go or Java, ensuring seamless communication, store information in databases built with C++, organizing vast amounts of data, and analyze trends with Python, unlocking insights and driving innovation. An entire chain of languages works together, a collaborative effort behind every interaction, to make modern life possible, connecting us in ways never before imagined. The evolution continues. The story of code is far from over. Quantum computing and AI will demand new languages, pushing the boundaries of what's possible, and new ways to communicate with machines, bridging the gap between human thought and artificial intelligence. The drive remains the same, a fundamental desire to create and connect, to find better, more human ways to express our ideas to technology, making it more accessible and intuitive. The languages we invent shape what we can create, influencing the future of innovation. Next time you unlock your phone, a simple act we often take for granted, remember the invisible world of code at work, the intricate network that powers our digital lives. Generations of thinkers and creators built these languages, a collaborative effort spanning decades, each a key to new possibilities, unlocking potential we never knew existed. From room-sized machines, behemoths of early computing, to global networks connecting billions of devices and people, programming languages are one of humanity's greatest inventions, a testament to our problem-solving abilities. They are the language of our age, shaping our present and defining our future. And they are the tools with which we build tomorrow, crafting a world of endless possibilities.